Hello, welcome. Let us start our 7th lesson of statistics. Today we are going to talk about the topic histogram. You may remember the topic from previous lessons, especially when we talked about it in lesson 6. As you remember, histograms are useful visualization tools that work for numerical data. They do not work for categorical data, for example. We have seen several examples of histograms, and we coded histograms in previous lessons, both in Python and in Excel, but this time we will go into the theoretical and also some practical aspects of histograms. In particular, in this video we will try to answer some of your questions, such as what is the origin, the history of the histogram, and why is it important? How does the width of the bin affect the shape of a histogram? So when you change the width of the bins, of the bars, how does this affect the overall shape of the histogram? Are histograms and bar graphs the same chart, or are they different charts? And why do bars touch in a histogram but not in a bar chart? If you are curious about these questions, stick around until the end of the video. We will cover the theory first, and then as a plus, and only at the end of the class, we will have fun, let's hope fun practical examples, provided in Excel and also in Python. So stick around and stay with us. Let us start at the origins of the histogram. So for that we will give a little bit of history and background. And we will start with Karl Pearson, the famous statistician. He was responsible for introducing several statistical tools and graphs, and one of them was the histogram. But it may be in debate whether if he was responsible for inventing the histogram, if he was actually the first one to use the histogram, or if we should only give him credit for giving it a name, for providing it with a designation. Regardless, and in any case, if Pearson were here today, he would be probably very surprised, even astonished, to see how the histogram became one of the cornerstones of statistics. Another thing is that many people think that the term histogram is related to the word history. In fact, authors and researchers from the field of the history of statistics have shown that this is probably not true, and that the link is not so clear. They argue that the histogram does not share a stem with the word history. In fact, Karl Pearson did not even mention the word history in his earliest works. Instead, the word histogram has its roots from a Greek word, and the Greek word means anything set upright, which actually makes a lot of sense, since we have vertical bars in the histograms which are set upright. Do you remember what a histogram is? Well, in very simple terms, a histogram is a graph that shows you the frequency, the number of different values, numerical values. It is only applied to numerical data again, using vertical rectangles. Because we use these rectangulars, the graph is very similar to a bar chart, a vertical bar chart. However, to distinguish between the two, between the histogram and the bar chart, the rectangles are in connection, they touch each other in the histogram, only in the histogram. Since in the bar chart the rectangles are separated. These rectangles, both in the bar chart and in the histogram, are called bars. However, in a histogram, a bar covers a range of numerical values. This range is what we call a bin. Bins can also have other names, such as, for instance, intervals, classes, or buckets. Giving it a metaphor, you can try to imagine each bin as a bucket with many little marbles inside. And the marbles are the data points, the observations. And when you count the number of marbles in a bucket, you have the bin frequency. There is no clear rule saying how to do the binning, how to bin a histogram. And by binning I mean to define the bin width and consequently the number of bins, or to select the number of bins and then get the bin width. Regardless of the method, when we are creating a bin, we have to decide on the best number of bins. And a lot of binning is done based on the judgment, the singular judgment of the data analyst. It is the famous case of the egg and the chicken. First comes the bins, or first comes the histogram. It is a circle since you need to select the bins carefully to obtain a powerful histogram. But you only know if the histogram is good once you select the bins, once you do the binning. In reality, what happens is that bin selection, binning, it is an iterative process. We start by choosing the bins, then we create a histogram, we evaluate it, we refine the bins, we create another histogram, and so on. But in the end, it's about doing the binning in such a way that you display the information you need in the best possible way. A good histogram will help you show areas of higher and lower frequency, and in turn this information is helpful because you can identify patterns from the data. Setting the wrong bin size, setting the wrong number of bins will defeat the entire purpose of creating a histogram. And the purpose is to explore, but also to understand and to communicate data. So let us see two extreme cases that will help us to understand the importance of binning. For example, one bin will only show the population or the total sample size. In contrast, a bin for each sample point will provide little information because it will stretch the width of the chart and it will give you a lot of vertical bars, very tiny vertical bars. In some cases, choosing bins can be done by hand. This requires a lot of practice in looking at the data and also at figuring out what is the best number of bins. When dealing with large volumes of data, it is a best option to use algorithms to assist you in the binning process. There are a few general rules for doing the binning, for choosing the bins. The first one is that the bins should be all the same size. Even though there are histograms, or at least you can create histograms with an uneven bin width, this is not a common option and this is very tricky to understand and to interpret. Second, the boundaries for bins should land at whole numbers whenever possible, of course, and this is because it makes the chart much easier to read. Also, when setting the number of bins, usually choose as a general rule between 5 and 20 bins. And the thing is, the larger the data set, the more likely you are to want to choose a large number of bins. For example, if you have 10 data points, this might be well represented by 5 bins, but if you have 1000 numbers, this will be much more useful with 20 bins, probably. The exact number of bins is, however, in the end, a judgment call. Fourth rule, if it's at all possible, try to make your data evenly divisible by the number of bins. For example, if you have 10 data points, work with 5 bins instead of 6 or 7. Fortunately, there are heuristics to help us choose the number of bins to perform the binning. One such rule is the Sturge rule. It's widely known and widely used in statistical packages, for example, from Excel and Python, and it helps us to make histograms. The formula is the following, where k is the number of class intervals, so the number of bins. You have the n being the number of observations in the set, and the logarithm is the 10th logarithm of the number. Less popular, but not necessarily less effective, are other techniques, such as the square root choice, Rice's rule, Dunne's formula, Scott's normal reference rule, and Friedman's diaconist choice. When we create a histogram, we provide a visual representation of the data distribution. Histograms, importantly, can display a large amount of data because they group the data into bins and they show the frequency of those bins. And you can see with the histogram, you can see the peaks of the distribution. For example, the mode bin corresponds to the highest bar of the histogram. Histograms also allows us to see if the distribution of the data is skewed or symmetric. A skewed distribution is one that is asymmetric, and it can be inclined to the left or inclined to the right. Ideally, we search for datasets that are symmetric and with only one mode, unimodal. These datasets are easier to handle, as we will see further on. In contrast, multimodal or bimodal distributions are much more difficult to handle statistically because they have more than one peak, and this makes their analysis much more tricky. Regardless of the shape of the distribution of the frequency distribution, the histogram allows us to analyze its representation. As noted before, a histogram can be used to represent the frequency distribution of only grouped numerical variables. When your variable of interest is not a grouped numerical variable, or it is a categorical variable, we need to use a different chart type, such as, for example, a bar chart. When the variable takes on discrete numerical valuables, we can plot the variable either with a bar chart or a histogram. If you can group the data, then use a histogram. In the other case, use a bar chart. A rule of thumb is that you use a histogram when you have a lot of different unique values to plot. One major thing to be careful is that the numbers in your data have to be representative of a specific value. What does this mean? If the numbers are just codes for a categorical value, for a categorical variable, then that's a sign that a bar chart should be used. For example, if you have survey responses from 1 to 5 encoding values such as strongly disagree to strongly agree, then the frequency distribution should be not visualized with a histogram but with a bar chart. The reason for this is that the differences between the 1, the 2, the 3, and the 4, and the 5 may not be consistent. We don't know the meaningful difference between a strongly disagree and a disagree, or between a disagree and a neither agree nor disagree. So, as we have previously talked about when we saw the categorical data chapter, it doesn't make sense to assign numerical meaning to categorical values. Welcome to the tutorial of Python of the course of statistics. We are now in lecture 7. We are going to discuss the topic of histogram, and we are going to make a beautiful histogram with the package seaborn. The package seaborn is just another visualization package similar to matplotlib, where you just go to another level because it's essentially very good at generating nicer plots. The trick is you need more code, and it's not always the most straightforward way to optimize the plot. But let us try. So the number of bins, it's going to be 12 because I'm going to generate 1000 points, data points, and these two lines here are about defining for example, the figure size and other important properties. You just can copy them. And then we have these 3 lines here, which are very important. And the first one is about setting the seed. I'm going to generate numbers random numbers, and I want them to be exactly the same so that the histogram always has the same shape every time I run this code. So for that I set the seed to a fixed number. It's 0, it could be any other number. Then I'm going to define the numbers by calling the normal. So they're going to be in the shape of a bell curve. They're going to be located around the center of 100 and with a standard deviation of 20. And they're going to be 1000 data points. This third line is tricky. It means that I need to do a data transformation on the data that I generated in order to use it on my histogram plot. It's just fundamentally a transformation. And then I set some properties. And importantly, I need to set the boundaries of the histogram plot. The histogram plot needs a vector with the boundaries of the bins, so I need to call this function to have these boundaries calculated for me. The histogram plot receives several parameters. Importantly, I have parameters to define immediately the color and the alpha, the transparency of the bars. But I want to go a little bit further, so I have all of these lines where I define some additional properties. If you want to know more about how to set these properties, you can go to the Seaborn library website and check the options available. This is also options that I set, and hopefully I get a beautiful chart. Okay, so we have our chart here. It is defined according to my preferences. You could change the parameters to define it as you want, but it is a different way of using the visualization tools of Python. I hope you have enjoyed the lecture and also the example in Python. Thank you for watching this video, and see you next lecture.